9, 8,
Launch auto sequence has
7,
started.
6, 5, 4.
Hello, everyone, and thanks for joining us for our launch today. Falcon 9 is set to lift off from Space Launch Complex 40 in Florida just under 17 minutes from now. Our 243rd overall mission to date and our 44th mission of the year. My name is Jessie Anderson, and I'm an Integration and Test Engineering Manager here at SpaceX. And today we have a really cool payload on board the second stage. We're sending a space telescope for the European Space Agency to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2, which is nearly 1 million miles beyond Earth's orbit. This telescope's mission is to help answer the question...
Stage 2 LOX float has started.
To help answer the question, what is the universe made of, by exploring the cosmic mysteries of dark matter and dark energy. It will create an unmatched 3D map of the universe by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The mission today was named after Greek mathematician and founder of geometry Euclid of Alexandria. And since the density of matter and energy are linked to the geometry of the universe, the mission was named in his honor. The spacecraft today was built by the European Space Agency, or ESA, with contributions from the Euclid Consortium and NASA. In fact, over 3,500 people from 21 different countries were involved in making today's mission possible. After launch, Euclid will have a month-long commissioning phase while traveling to its final destination. After 2 months of performance verification, it will then be ready for its science operations to begin. ESA will need some time to process the data, but is anticipating sharing the first images with the public in the fall. In just a few minutes, we'll be joined by members of the ESA team to talk more about the mission, so stay tuned. At T-minus 15 minutes and counting, we're well into propellant loading on the vehicle. Both the rocket and spacecraft are healthy. Weather is green and looks great over there in Florida, and rain. We begin that shift in orientation by gimbaling the engines so Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. With about 7.5 minutes left until liftoff, we are joined by NASA's Megan Cruz and ESA's Director General Joseph Aschbacher over at Kennedy Space Center in Florida. Hey, Megan, how's it looking over there on the East Coast?
Hey, Jesse. Welcome, everyone, to Florida and NASA's Kennedy Space Center. We're just behind us. We are waiting to see Euclid launch on a Falcon 9 rocket right off the launch pad behind us. As you said, joining me this morning is Joseph Aschbacher, the Director General of the European Space Agency. Good to have you here this morning.
Glad to be here every time.
Yeah, I love that you're here. And yeah, just talk to us about how Euclid's launch that we're about to see in a few minutes comes on the heel of a great year for you guys at ESA.
ESA had really a fantastic year. We just came out of a ministerial conference in November last year, plus 17% more budget, many new projects, many new activities, so quite fascinating. We have selected 17 astronauts. Some of them will fly from here into space. We have just signed an agreement with Axiom. We're having 5 astronauts in training right now at the Astronaut Center. We have launched JUICE earlier this year. JUICE is an amazing mission which fits very well with Euclid, which is looking at habitability of the icy moons of Jupiter, something quite unimaginable, just as crazy as Euclid, dark matter, dark energy, which is really amazing. So we have a lot to do. We have a Space Summit coming up towards the end of the year, where we want to raise the profile of space in Europe to top-level politicians and to see what Europe needs to do to really be a strong space power, also to our partners in America.
Right, and in order to foster that, the space industry, I mean, one of the reasons you really want to do that is to also address a global issue that we here at NASA really care about as well.
Oh yes, we do. We have many satellites that look at our planet. Climate change is the largest problem on our planet for many decades to come, if not centuries, and we need to do everything we can from space. We have the Copernicus program, we have Meteor program, we have just launched MDG-1 last year, fantastic images that just came out, and we really make sure that we use our space assets to the best of humankind, and climate change is one of our big concerns. And one element which we just launched is not only on ground that we want to see at climate change, also in space. And I'm about to really initiate a zero debris charter where we would like to encourage people worldwide to not pollute our orbits. That means if you put a satellite up, you put it down at the end of its lifetime, and that's a new initiative we are doing.
Great. And any words for all the scientists that are hoping to really learn a lot from this Euclid mission?
Oh, the incredible science will come out. I'm pretty sure some Nobel Prizes will be won based on this data. This is really a fascinating mission. I'm so happy. I thank my community, my member states, industry, NASA also as a partner, and all the contributors to this. And thank you so much for this contribution.
Well, congrats to you, and I can't wait to see Euclid launch.
Thank you.
Thank you so much. Back to Hawthorne.
Thanks, Megan. We are about T-minus 4 minutes and 40 seconds away from liftoff. And at this point in the countdown, the clamp arms are going to begin to open up beneath the fairing, and then the transporter erector will begin to retract away from the vehicle in preparation for launch.
Retract has started.
And there we heard that call out. And you can see the clamp arms just below the fairing there on your screen. Those should begin to open shortly here. Once those are fully open, then the transporter erector, or what you heard called the strong back, will retract away from the vehicle. And there you can see the clamp arms opening up there. Again, once those are fully open, the TE will begin to slowly retract away from the vehicle. And it is very slow and slight, but the TE is now beginning to move away from the vehicle. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both first stage and second stage should finish prop loading about a minute apart from each other. First stage finishing up at T-minus 3 minutes, and second stage at T-minus 2 minutes. At T-minus 60 seconds, Falcon 9 will be in startup. Now, what that means is the rocket's autonomous internal flight computers will have taken over the launch countdown. Just inside of T-minus 2 seconds, we light the Merlin 1D engines for liftoff. The Euclid payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Currently, both the vehicle and payload are healthy.
Stage 1 LOX load is complete.
And we're looking good for an on-time liftoff at 11:12 a.m. Eastern Time. So let's send it back to Megan over there in Florida.
Hey, Jesse, you can start to feel the energy here at NASA's Kennedy Space Center. We're just behind us. We are waiting to watch the Euclid spacecraft launch atop of Falcon 9, again, on the launch pad right behind us. So with me now is Carol Mundell. She is ESA's Director of Science. Really great to have you here today.
Hi, Megan. Great to join you.
So talk to me about why studying dark matter, dark energy, why is that so important to understanding our universe?
Yeah, sure. This is one of the biggest unsolved problems in modern physics. So we actually think we understand only 5% of the universe, with the matter that we see, galaxies, stars, planets, ourselves. So 95% of the universe, dark matter and dark energy, is still a mystery and enigma, a huge frontier of modern physics that we hope this mission will actually help to push forward.
So then how do you go about detecting things we can't see?
That's a great question, and of course this sense of darkness really comes from the fact that dark matter does exert gravitational pull, so we see the effect of it. We look at galaxies and they spin too quickly for the number of stars and the amount of gas they have. We look at the clusters of galaxies in the universe and we see too much mass. And so we don't know what fills that mass. It might be exotic particles, it might be that we've got our equations wrong. And on top of that, our universe is expanding. But the really big mystery for modern physics is that that expansion is accelerating. So it's actually getting faster and we don't know why. Our equations don't tell the whole story. And so what this mission will do is it will map all of that out to 10 billion years back in history and hopefully tell us the answer to the mystery of life, the universe, and everything.
So then really quick, when do we expect to get this data back to start really analyzing it?
Yeah, so this is a 6-year mission, and the first 3 months of the mission will actually be calibrating the data because this is a huge feat of engineering technology. We have very, very precise images across all of the extragalactic sky, and then scientists around the world, we have 2,500 scientists in Europe and in the US across 9 data centers will analyze these data all the way through 6 years. So our final cosmology answers will come at the end of the 6 years, but we'll do lots of exciting science along the way as well.
Carol, thank you so much. Very exciting.
Thank you.
Thanks, Megan. Thanks, Megan. We are just under 1 minute. Falcon 9 is in startup, and we are just waiting for the final go for launch.
LD, go for launch.
And great news. All systems are go for launch of Falcon 9 and ESA's Euclid Space Telescope.
T-minus 30 seconds and counting. T-minus 15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Into ignition. Liftoff.
Stage 1 propulsion is nominal.
Vehicle is pitching downrange.
Falcon 9 has successfully lifted off from pad 40 and throttled down to prepare for max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds. Max Q is the highest amount of aerodynamic pressures. That's the largest structural load that the vehicle will see on ascent. We throttle down those engines just to pass through max Q, and then we'll throttle them back up once we pass through that period.
Falcon 9 is supersonic. Maximum dynamic pressure.
And great news, we have passed through max Q. You're getting some excellent views there on your screen. Next up, we have a few events happening back to back. That will be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
stage separation. And that's where the first stage separates from the second stage. Right after stage separation, the first stage will begin its journey back to Earth for landing on our drone ship, a shortfall of gravitas. And during that time, stage 2 will continue on its journey with that third event, SES-1, or second stage engine start 1. And that is where the single Merlin vacuum engine will light up and propel the second stage along with ESA's Euclid spacecraft to orbit. In addition to these 3 major events, the fairing halves will separate less than a minute after SES-1, so keep an eye out for all of those events coming up here in just about 15 seconds or so. Again, coming up, we have MECO, stage separation, and SES-1.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
Some really cool views of MECO stage separation, and on your right-hand screen, you can see that the MVAC engine has ignited.
Both vehicles are following nominal trajectories.
On your left-hand screen, the grid fins on the first stage are deploying, and in about 15 seconds or so, we should have fairing separation. And a very cool view from the ground.
Fairing separation confirmed.
And there you can see on your right-hand screen that the fairing halves have deployed. Now, as I mentioned previously, both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel, Doug, today. It is T plus 4 minutes into today's mission. And in order to complete today's landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where 3 of the Merlin 1D engines will reignite. This helps to slow the vehicle down as it re-enters the upper parts of the Earth's atmosphere. Now, that entry burn is coming up in about a couple minutes from now, and that entry burn will last about 20 seconds long. And what you're looking at on your screen, on your left-hand side, is a view from the first stage vehicle, currently making its way back down to Earth, which you can see in the background. And on your right-hand screen is a view from the second stage looking aft at our MVAC engine.
Acquisition of signal, Bermuda.
That entry burn is coming up here just about a minute and a half
Both
from now.
vehicles continue to follow nominal trajectories.
And good callouts there. On the bottom of your screen, you can see the speed and altitude of each vehicle as well. And on your left-hand screen, you can see 2 of the 4 hypersonic grid fins that the first stage has. Those grid fins help guide the vehicle as it makes its way back to its landing zone. Again, today we are scheduled to land on a shortfall of gravitas, currently in the Atlantic Ocean, waiting for the first stage vehicle. And on your screen, you're getting a great view from the second stage with the MVAC there and the Earth looking amazing in the background. We're just about 20 seconds away from the entry burn on the first stage vehicle. You may see some white puffs on that first stage. That is nitrogen gas puffs for attitude control.
Stage 1 FTS has safed.
And there you can see the engines have reignited on the first stage on your left-hand screen. This is the entry burn with 3 of 9 M1D engines reignited. And you can see that those engines have shut down. That concludes the entry burn for the first stage. Now we do have one more burn for the first stage vehicle as it attempts to land on our drone ship, and that is the landing burn. It will just be a single engine, the Center E9 engine reigniting, and that is enough thrust to help slow down the vehicle to enable it to touch down on our drone ship. Now, during the first stage landing burn, the vehicle will be landing for its second time.
Stage 2 FTS is safed.
Stage 2 terminal guidance.
The vehicle will be landing for its second time today, and just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission, and that is coming up here in just a few seconds, followed by the landing burn about 20 seconds after that. There you can see that the MVAC engine has shut down and the landing burn has begun on the first stage vehicle.
Expected loss of signal, Cape. Nominal orbit insertion.
What an incredible clear view of Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 204th overall successful recovery of an orbital class rocket, including both Falcon 9 and Falcon Heavy first stages. We also heard the call out for SECO 1 and confirmation of good orbit. So with confirmation of a successful second engine cutoff and first stage landing, we are going to be in a coast phase until just before the second relight of our MVAC engine on the second stage, which will be followed by payload deploy. So sit tight and we'll see you back here around the T plus 17 minute mark. Thanks for joining us once again for the Esa Euclid launch. We've had a great mission so far, and we have just one more major milestone left in our mission, which is payload deploy. Built and operated by the European Space Agency, or ESA, with contributions from NASA and the Euclid Consortium, the Euclid spacecraft will be operated from European Space Operations Center in Darmstadt, Germany. It will explore dark matter and dark energy, which combined is known to make up 95% of the universe as we know it, and create an unmatched 3D map of the universe with time as the third dimension by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The deployment is coming up here in just a few seconds.
Euclid spacecraft separation confirmed.
And there you can see the Euclid payload drifting away from Falcon 9's second stage. With that confirmation, we'll bring today's webcast to a close. Today's mission marked SpaceX's 243rd overall mission to date and 44th mission of this year. We want to thank the European Space Agency for entrusting us with today's mission and all of you for joining us. If you're interested in following the Euclid mission further, tune into youtube.com/ESA for more. And be on the lookout for the first images from the Euclid telescope later this fall. Thanks for tuning in, and we'll see you again soon.